All right, what up, everybody? This is Mr. Stan coming at you with another physics video. This time we're talking about the electromagnetic waves and how to find the wavelength and frequency. And it turns out that if we know the wavelength, we can find the frequency. And if we know the frequency, we can find the wavelength. So as long as we know one of the two, we can find the other one. All right, so on the screen, you'll see the electromagnetic spectrum. And some electromagnetic waves have very long wavelengths and smaller frequencies, yeah. And so these are called radio waves. And then some waves have really high frequencies and really short wavelengths, and those are gamma waves. And different types of waves fall in between. Okay. Now here's the equation that we'll need to find the frequency if we know the wavelength, or find the wavelength if we know the frequency. It's C equals F times lambda. Now, what does C mean? C is equal to the speed of light, and the speed of light is 3 times 10 to the 8th, and that's how fast light travels in a vacuum. Now, if it goes through a material, it slows down some. However, when it goes through our atmosphere, if it's just going through the air or through the room, um, the speed is very close to 3 times 10 to the 8th, right? It only loses a tiny, tiny bit of speed when it goes through the air. If it was going through like a solid substance or water, then there'd be a significant difference. But because it's so close, we can go ahead and use 3 times 10 to the 8th, right? Even if we're talking about waves that are going through our atmosphere. And if the F stands for frequency, which are these top numbers that end in Hz for hertz. And the Greek letter lambda stands for wavelength, right, which is measured in meters. So here's an example. A GPS device uses a frequency of 1.2 times 10 to the ninth hertz. What are the wavelength of these waves? Okay, so we're going to start with the equation. And the C is equal to 3 times 10 to the 8th, because that's the speed of light. And the F is equal to 1.2 times 10 to the ninth. Okay, so then we need to use algebra to solve for this lambda, because that lambda represents the wavelength of this wave, which is what we want to find. So using algebra, the next step would be to divide both sides by this term right here, 1.2 times 10 to the ninth. All right, now how do we do this? We're going to go to an online calculator, type in the scientific notation number that was on top of the fraction. And we'll do that by having parentheses. And inside the parentheses, I just go 3 times 10. It's supposed to be 10 to the 8th, so I'm going to come over here to this button. There's a little A in the bottom and B in the top. And put 8. Right, and then I'm going to press the divided by button. And on the bottom, we're just going to go ahead and put in the scientific notation number that was on the bottom, and that was 1.2 times 10 to the ninth. So first type in 10, then press this button, and then put 9. All right, and you see that when I do that, it's actually equal to 0.25. So let's go back to the 0.25, which means the wavelength of these GPS waves would be 0.25 meters, or 25 centimeters. Let's look at another example. This time we're going to find the frequency. It gives us the wavelength. Okay, so the gamma ray has a wavelength of 3.2 times 10 to the negative 12. So that's an extremely small wavelength. With scientific notation, if you have a negative sign on the 10, that means the bigger that negative number is, the closer the value is to 0. It gets smaller and smaller. So we're going to use the equation again. C equals F lambda, which means the speed of light, 3.3 times 10 to the 8th, equals the frequency times the wavelength. So to find the frequency, now we're going to divide both sides by this term, 3.2 times 10 to the 12th. To do that, we will go back to um, it's on the calculator. We have 3.8 at the bottom already. Let's type in 1.2 times 10. I'm sorry, 3.2 times 10 to the negative 12. Okay, and then you get the value over here. It's a big number. It's 9.375 times 10 to the 19th. Right? So that's the frequency of the gamma wave. And remember, since gamma waves have a very small wavelength, they have a large frequency.